encoder and one hot. When it comes to label encoder and one hot encoder, there is a little bit confusion.
Okay.
We didn't find the mm, exact code, sir. How we have to write for this syntax for this one hot encoder, sir.
Mhm.
Sir?
Yeah, yeah.
Yes.
So whatever the library name you have imported, is it correct? See, did you apply label encoder at least?
Sir, yes, the label encoder is already there.
Okay.
But this is what I I tried, sir, but not getting, sir. Not getting the data what I wanted, sir.
Okay. So did anyone try?
You explain what is the correct syntax or what is a nearby syntax to write one hot encoder that will be useful, sir. Sir,
Yeah, then we can start. So apart from that, did you complete the remaining flow except one hot encoder?
yes, sir, yes, sir.
Did you complete the model training?
Sir,
Model training.
yes, sir, yes. Nominal,
Okay. So what about remaining fellows? Okay. So let's discuss the project first. Then move on to the one hot encoder. So if you go to the project, so this project is related to one insurance company where it will be having multiple application numbers. Application number is related to the customer. So is NR is nothing but number. Don't confuse. And the next code generated date is, so at which date the code got generated. So our next feature is offer coverage amount. So how much they coverage amount, so how much offer they got on that particular scheme. They will be conducting multiple offers, right? So next, some statistical reasoning and something they maintaining this void signed. So whether it's a signed or not. So is there any person not signed? Something else like that. That information they collected. So what is the premium amount? So how much premium amount they paid that particular person and that particular application number. So like normally if you go to any insurance company, the premium amount will change from one person to another person. So one person paid $13.75 and other person paid $74.8. It's completely based on the that premium and that the offer coverage amount, how much they are taking, and at the same time the age of that person also will matter here. So first person they have taken only 15,000 offer coverage amount. In the next it is around 10,000, I think. So 10,000 or 1 lakh it is. It's 10,000 on it. But maybe this person is having age, his age could be senior citizen or something else. And the billing method. So on which mode he is doing the payment. So whether credit card or debit card or something else. So the frequency. So whether he is paying monthly or quarterly or half yearly like that. Next, effective date. From which date the policy is going to happen. So it's like from which date he is holding the policy. So here there is no data mentioned here. So somehow there may be a typing mistake. Somehow they didn't get time to fill this value. But in this column, in this row, we got the value got filled. So it's around 8th February 2008. NEAT is nothing but null value. So both are same. NEAT, anything is fine. So paid to date. So at which date it has to pay. So 8/9/2022. That means maybe they have taken some term policy and it is 4 years of duration. They need to pay this premium. So next, offered NAP. So how much they will be having some NAP values they will be maintaining the insurance companies. So how much they have given offer. So here issued NAP. So if they give any offer, this issued will be reduced. So if they didn't give any offer, it won't reduce. So next, current billing method. So maybe they are maintaining some billing methodologies like PAC and some other methodologies will be there. So now what you need to do, you need to check each and every column. So that is where the data analytics come into picture. So next, the product type. See, like the policy type. See, it is whole life. So in the LIC, we will be having multiple policies, right? Like LIC, HDFC Bank, some other companies, Tata, all those things. Here, age at application received, the age of the customer. So here the age is 53 and here the age is 70. As we already discussed, for the 70 years person, always the premium will be high and the less age person, always the premium will be less on them. And next, partner. So each and every company will be maintaining their partners. For example, if Tata is providing policies, those Tata policies will be sold by HDFC Bank, Axis Bank, SBI, some other things. Those will be called as partners. So anyway, I do have exposure to this data. So that's why I was able to expand. Then how in your situation, how will you handle if you get this data set directly from your client? Your client just asks you, hey, I want you to do the grouping of this data. I want you to divide this customer's data into multiple clusters. Like that, he asked. And next, what you need to do, you need to understand each and every feature. And if you don't understand the specific column, you can check with your manager or client. So that is a regular phenomenon problem. So even if I am working with any new domain, if I don't understand any new terminology also, like related to data, not machine learning or deep learning. So related to data, we can ask our manager. Even if I get any doubts, even I will ask my manager. So what is this meaning? So what is this feature meaning? So what is the use of this feature? So can I maintain this feature in my data set or not? Like that, you need to discuss with your manager or client, whoever available with you. If you are availability of lead, you can discuss with your lead. So what I'm doing, simply checking header, tail, shape. So as usual, it will represent how many rows of data. So like how many rows. So 4,58,000. So that means this company is having this many customers. So 4,58,000 customers, and the 15 is the columns. So that customer information on those. Next, I am simply checking the info. So how many date time columns are there? See here. Code generated date by default it is in date time 64. NS means nanoseconds. And here object. Normally here application number is numerical data. Here application number is numerical data with some little bit ABCDs. So by default it will consider the entire row as an object. Object is nothing but string. You need to understand and you need to remember. If you are seeing object means you should understand this is string data. In some scenarios, whenever the database persons are saving the data, some numerical data also they will be saving in object format. So that is data mismatch. So at that scenario, what we need to do, we need to convert that object data into numerical data based on our requirement. So here float values, float 64, and here it is integer 64. If you see all the data types got covered in the same data set. So first object data type, it got covered. Next datetime data, it got covered. Next integer, it got covered. So float, it's got covered. Everything, the four data types got covered. So the four data types is one is integer, float, object is nothing but string, and next is data. So these are the main four data types. Another data types like images, videos, that is secondary subject. We'll discuss whenever we are going to deal with images and videos. So till now you are able to at least do some analytics on the data set. Till model building, everything is data analytics and data pre-processing only. So now next, my client asked me, or your manager asked you, hey, I want you to extract year and month from the data, from the code generated date. If you see the code generated date, it is date, month, and year. I want you to extract only year and month. So this is the task which assigned. So for that, you need to use this pandas datetime library. So by using this datetime library, we will be stripping. strf time means we are stripping. So from the entire date, month, and year, I am just extracting year and month. So if I want to extract a day, what I need to do, I just need to use hyphen percentile D. So it will fetch year, month, and day. Why? In some scenarios, you will be getting time like this also. So today, if I take 28, 11, 2023, and next the time is 12, 23, 35 seconds. So if you are getting date time like this, you need to extract year and month. And some scenarios, some foreign countries, they will write date like this. The same time, normally they will reverse date and month. So normally, as an Indians, we will be writing date at first. But in foreign countries, they will write this 11. That means month they will write first. So it's up to them. We need to identify that also as a data scientist. If you see in which format our data got saved here, see here the format is completely different. So first year came, next month came, next date came. It's up to them. Okay, like this, the formats will be changed. We need to identify this. So here, first it is mentioned year. That's why in my strip time, I have taken percentile Y here. If you see the code pattern. So Y, month, D. So for example, if my data like this, if my time is like this, let us start this. Time is like this, the code will change. So let us copy the same line of code. So here, first day it is coming, next month it is coming, next year is coming. I want to extract month and year only. So what I need to do? First, I need to mention month. Next, I need to mention year. That means I don't want to fetch data. So here the pattern is completely changed. So here it is a year and month. Now here it is month and year. So based on the data set, based on the data, it got saved. We need to change our methodologies. So that is now, see here. In this example, I am extracting only year. I am extracting only year. So by default, it will understand. Anyway, why? Because year, it will be saved with 4 letters. Month, it will be saved with 2 letters. That is 2 digits. And date, it will save with 2 digits. Like that. So these are all the data pre-processing. We need to clean up the data. We are cleaning here. So based on our requirement, so EDA is nothing but exploratory data analysis. Exploratory data analysis. Data analysis. So we are doing data analytics and we are explaining the things to the manager. So next, what he is asking, I want to check month-wise, year-wise offer coverage amount. That is the next thing he asked. So next, what we are doing, we do have a concept called grouping in pandas. So what I'm doing, I forgot to tell you, this lambda function. So the use of this lambda function is, if you see the code here, I am applying on the entire column. I am applying the entire column. So lambda, it will take each and every row and it will apply this functionality of stripping. And after stripping year and month, it will save in the feature called quote year month. Okay, you guys should write each and every line of code. After this line, again, you need to check the header. You need to see how this line of code works. So then only you can understand easily. So next, what I'm doing, year-wise, month-wise coverage sum. So on February 2018, how much coverage sum got covered? So how much coverage got added? So if you see here around 33,79,000 coverage. On March 2018, 79,88,000. Normally they will be asking this type of task to summarize the things. So on which month, how much business we got. So on February, how much coverage we got. So on March, how much, April, how much, May, how much, like that. So they will check. Normally, if you see here, in the February, it is 33,000, but in the March, it is completely doubled. It's completely rapidly increased. So here the reason is, normally at the financial year ending, everyone will try to take the policies. So everyone will try to pay the premium. So that's why they got huge coverage. So in this type of inferential data analytics, we need to tell to the clients. Then only they will understand. So how it will come? So it will come through practice. So if you keep on testing multiple data sets, if you keep on checking multiple analytics like this, then you will get to know. So next, it's like checking each and everything. What you need to do on this coverage sum, you need to do the plotting. So that is what I did in next thing. Next, what I did. So this is month-wise and year-wise total coverage. Next, I calculated year-wise total coverage. It's like checking. So each and every year, how the business got improved. So whether the business is improving or not, it's like checking. See, here it is around 1 crore 79 lakh. Here it is increased. Year 10. Here it is 25. Here it is 72. Here it is 81. That means the business is rapidly increasing. They are getting a lot of profits. So there is no dip in the business. So it's not decreasing. Even though it is increasing and decreasing month-wise, see in the 5th 2018, it is 67,000. But on June 2018, it's 65,000. No issues. But when I calculated yearly, that is 2018 entire yearly, I was able to see clear growth in the coverage amount. So that is what I did. So here I did with bar plot. We can take another plotting. We can take another plotting. So try with the line plot, something else. You need to try with all the plots. Then only you can understand underlying meanings behind everything. So next, what I'm doing. So the same thing. Coverage sum we are doing year wise. So quote year. So where is the quote year feature for me? This year this feature I created and this feature I created. So we created these two features. Till here only the client provided data. But from quote year month and quote year, we are fetching. We are creating those two features and we are making it. And next, immediately what my next step? So I was able to do some basic analytics. I'm just checking null values. So what is this application number? So application number is having 10 null values. So till here there is no null values and some effective date, some null values around 2,68,000. See, my data set is 5 lakhs, but in that 5 lakhs, I do have 2,68,000 null values are there. So if I drop this 50% null values, I can't build my model. So this 2 lakhs rows is not enough for me to do the clustering. So let us see how it will go. So if you see the application number, here on the application number, we do have 10 rows of data having null values. So if application number is not available, that means the identity of the person is not available. So the person is not identified. So somehow randomly it got came. So what is the use of having the data, whichever we don't know? So if I know any person, then I can save your number. So if I don't know your name, anything about you, what is the use of maintaining that? So that's why I'm dropping this 10 rows of data by taking this application number as subset. So if I want to drop on one column, I need to write code of line of code like this, dropping null values. So here subset is application number. So it will remove. Before removing the null values, you need to check the shape. After removing the null values, you need to check the shape. Around 10 rows of data will reduce. So before removing null values, my data set shape is around 4,58,000. Let us copy this. You guys check it. Once if you execute the code, you will get clear picture. This is the step. So after this here we are not filling, we are dropping. Around 862 we will get. You guys should check it. 4,58,862, 1 5. That means 15 columns. Not 15 columns. I think you will get 2 more columns extra. Why? Because I created 2 columns, right? So that will come here. You need to check it. Just check it. So like here, I was able to remove some of the rows which are null values. So if you want to remove null values, these 40 null values also we can remove. So removing 40 rows, 30 rows is not a big deal. So we can remove it. So what you need to do? So here subset we have taken 1 column, dropping null values by taking multiple subset columns. So here what you need to mention, application number, comma, whatever the feature name, payment frequency descending, we can use this line of code to drop it. We can use this. So if you drop this 40 rows of data also will be removed. You need to check it. Everything you need to check thoroughly. Then only you will understand. Again, I am checking. See here, 862. 4,58,862. I told right. The same thing. But here 17 columns. Why? Because we created 2 columns from our data set. So next, I'm just checking the column names. So what are the column names I do have in my data set? We can check it by using this dot columns methodology. Just checking header and tail. And here, if you see here in the data, all the null values are related to date time column only. All the null values related to date time. So here it is effective date, and this is paid to date, and next is issued NAP, and next is current bill method, and next is age at application receipt. So this feature is important. This is customer information. We need customer age, and here also current billing method also needed for us. So how he is paying, whether it's monthly, quarterly, that is also needed. So here issued NAP. So this is also important for us. This dates related information, we don't need it. So for my model, this dates is not important. My model won't consider these dates. So that's why I will be dropping those date columns, and I will be taking the columns which are needed for me. That is what I'm doing. So for application number also not needed for the model. Only for data analytics only that application number is needed. But for model, we don't need. So this offer coverage amount, offer stat descending, offer premium amount, offer billing method, payment frequency, offered NAP, issued NAP, current bill, product type, age at application received, partner name. So these are all the features important for me. So that's why I have taken final data frame with these columns. And next, again, we need to check the null values. So again, I do have 2,68,257. I need to fill those null values. I can't drop this. Why? Because if I drop this 2,68, around 60% of my data will be dropped. So to fill that, either I can fill individual column at a time, or I can create a function and fill all the values at a time. So here I have followed a condition called if my data set is numerical, I just filled with the mean, and if my data set is numerical, I just filled with mean. If my data set is categorical, that is object, I filled with mode value. So in the mode, so normally whenever you have applied this value counts, in this value counts by default, it will provide higher frequency value there. So that's why I have taken index equal to 0, index of 0. Index of 0 means that is the first one. If you want to understand this line of code, what you need to do, you just need to take each and every line of code, you just need to execute, and you just need to see the output. So first, this line of code, you should take and you should print the output. And next, we should take this line of code, you should print the output, see, print continuous. Next, categorical, you need to print the categorical. Next, what it is doing. So what you need to do, you need to take, first you need to take this line of code. Till here. You should not take entire thing at a time. You should break your code. You should not take this index 0 also. First, you should check with the value counts. What is the output I am getting with the value counts. So next, you need to add index of 0. So after executing this, you need to see what is the output I am getting here. Index of 0 means the first output. Like this, what I am doing, what is the first output I am getting? I am filling that value in my null values. That is what it is mentioned. So here I is column name. For I in category means column names. So I for I in base data columns. If I not in base data are described columns. That means if my data set is not part of describe function, that means all of those columns are categorical columns. So either you can write the line of code in this typical manner, or you can write in the simple columns also, or you can mention the column names directly also. Like this, you can mention You can mention the column names. So column 1. Like this you can mention. It's up to you. But while going ahead, you need to improve your programming skills. That's why I have written this one complicated. If I want to fill it, I can just fill it with one line of code. Whatever the pandas null values filling sessions we discussed, right? By using that single line of code also, you can fill column by column. But you need to write column by column and you need to fill like that. So once if I execute this function, with this entire function, all the null values will be filled. So this meaning is, if my column is categorical column, it will fill with mode value, and if my feature is continuous value, it will fill with media. So again, I am checking the null values. So before filling null values, I am checking the null values, and after filling the null values, again I am checking the null values. So this is before filling the null values. I do have null values, but after filling the null values, there is no null values. Like this, you need to write function-wise codes in your real-time projects. Once it is filled, I'm just checking the info. So I'm just checking category, what are the categorical columns are there and what is the continuous columns are there. So next, we have already discussed this label encoder, all those things, one hot encoder yesterday. So once if I apply label encoder, so now my data got converted into numerical data. So whatever the categorical I do have, so it's converted into numerical. And next, what I'm doing, I'm importing K-means algorithm. By using the K-means algorithm, I'm just using I'm defining, I want you to create 3 clusters. If I change it to number of clusters 4, it will make 4 clusters. If I take 5, it will take 5. So random state equal to 10 means, we have already discussed, it's just like giving a random number. So by default, if you are taking the same number again and again, the same data will go to the model. If you don't take this random state number, the data will be shuffled. Anyway, in this clustering algorithms, we will be taking entire data set. So there is no, either you can take random state or it's up to you. What I'm doing, whatever the data I have encoded, I am just fitting to the model. And next, K means whenever it's run on our data set, it will create some labels on its own. So it will create cluster number. Here label means cluster number. It has to remember, right? So it has some rows of data, it has given 0 clusters. Some of the rows it has given cluster 1. And some of the rows it has given cluster 10. That is what it is meaning. So what I'm doing, these labels, I'm saving into one variable called labels. These labels I'm assigning to the cluster column. I created another column and this cluster column got assigned to my original data set. This base data label encoded is assigned to that cluster. So what it is mentioning here, this is the cluster. Cluster 1, 0, 0. That means that data I was able to cluster easily. So next what we need to do, we need to see. Here I have taken cluster 10. You can try with it. So I interpret the code, so that's why it can happen. So it will give 10 clusters. It has given 10 clusters of data. So in cluster 2, we do have a lot of data. So around 1,66,000 rows of data in cluster 2. So 98,000 rows of data in cluster 7. So 70,000 cluster 5. So 49,000 cluster 0. 5,000 in cluster 8. So cluster numbering will start with 0. Just checking. So next important thing is, in the agglomerative clustering, we have discussed about the concept called Silhouette score. In the same way, this WCS is also one of the methodology which we will be using to find out the optimal number of clusters. So Silhouette score, and WCSS we will be using to find optimal number of clusters. So that means how many clusters I need to divide. So whether 3 clusters, 4 clusters, 5 clusters, like that. And to divide in that manner, we will be using this WCSS, means within clusters sum of square. So we will be dividing our data into clusters, right? So within that clusters, we will be calculating the distance from one point to another point. So wherever the WCSS value is higher, and this WCSS value having in the format of elbow. Here what I have taken, on the x-axis I have taken clusters, on y-axis I have taken WCSS value. So first WCSS value is around 1.75, next 1.5, 1.251. So wherever it is standard, so wherever it's not reducing that much, it's not increasing that much. So after some specific clusters, it won't increase or decrease. It will be standardized. So that number we will be taking as optimal number of clusters. So in this example, either you can take 5 or you can take 6. You can't take 7.5. Why? Because clusters is 7 only we have taken. 2, 3, 4, 5, 6, 7, 8, 9, 10. But in the graph, it is representing like 7.5. So here optimal number of cluster, wherever the curve happened, this graph will be called as elbow curve, elbow method. So we can say by using the elbow method, we can find the optimal number of clusters for the dataset, whatever we call it. So wherever the elbow related thing happened, that thing we can consider as optimal number. Either you can go ahead with 5, or you can go ahead with 6, or you can explain this elbow graph to your manager and he will suggest. So based on the requirement, you can go, you can do 5 clustering once and you can showcase your result. And next you can do 6 clusterings and you can showcase your results. The optimal number of clusters are 5. So we are fitting the model with 5 clusters. So what I did, by using these 5 clusters as reference, I am building my machine learning model. I am dividing my data into 5 clusters. So in the same project, I did it with Silhouette score also. Execute the guys. This Silhouette score will take a lot of time. In the place of 20, what you can do, you can take less clusters. So you can take 6, 7. Why? Because or 8 you can take. Why? Because from elbow method, I was able to find out 5 is the optimal number of clusters. So let's check with the Silhouette score also, whether the Silhouette score also giving the same result or not. So next what we will be doing, we will be again retraining the model with 5 clusters. For that, what we need to do, again we need to take that model training code. Where it is. Yeah. So again, doing the same steps again. So once if you imported the library, there is no need to import again. And some of you guys still not able to find out the below I did it. So with 5 clusters, I built the model and I trained it. So labels, I was able to get it from the k-means variable. And these labels I have added to my data set, and the cluster I have created another column. So whenever I use these 5 clusters, my data set will be grouped in different perspectives. When I did it in 6 clusters, it will be divided into another. Like this, we will be dividing, we will be doing the grouping, and based on this grouping, the data will be showcased with the front-end team or marketing team or sales team or telecaller team. They will utilize on their own. So what I'm doing, I'm just doing the scatter plot. So in the scatter plot, I'm just taking these 2 features, X and Y. I'm just printing whether my clusters is happening correctly or not. To check it, so this is my first cluster, second cluster, third cluster, fourth cluster, fifth cluster. There is no clumsiness. So green is able to divide into green, pink, pink, yellow, yellow, blue, blue, red, red. So like this, we need to do the group. We need to print the clusters. So what I have taken to make it clusters into different color, I have taken these labels. I have taken labels as my another index. And CN means it will define the colors. So by default, I have taken the colors. So cluster 1, cluster 2, cluster 3, cluster 4. If we have more clusters, we just need to add another column, another row here. So simply y equal to 5 comma 0, y equal to 5 comma 1. So size is 50. I'm defining here. So here color I'm defining each and every cluster. So you can define another color here and you can name cluster 6. So whatever the data we got till here, base data label encoded, this is my final data set with clustering. This is my input data. This input data got clustered into multiple clusters. See, 0 cluster, 1 cluster, 2 cluster. So this data will be pushed back to the database. Or if your client need in the CSV or Excel file, you can save it. So this is the overall project related to clustering. So tomorrow I'm going to start either on regression or classification. We are going to discuss. So everyone, please complete this project on your own. Try to execute the code. Try to test the difference between Lahoti score and Lahoti score and this Elbow method. That elbow method is WCSS. So you need to explain clear whatever we have taken on x-axis and whatever we have taken on y-axis. On x-axis, we have taken number of clusters. On y-axis, we have taken WCSS value. So WCSS value is like whenever I divided my data into one cluster, the WCSS value is 1.75. Whenever I divided my into two clusters, this is my WCSS value. So here 0.75. So 4, it is 0.5. So 5, it is 0.25. So from 6 onwards, the value is constant, 0.202020. So in this scenario, either I can take 5th cluster or I can take 4 clusters. It's up to you. So if the WCSS value is not changing means till 5th cluster, the data is perfect. So it is recommending to create 5 clusters or 4 clusters only. It is not recommending more than 6, 7, 8. Either you can go with 6, that is also fine. It's up to the requirement. The requirement will change from time to time. This is how you need to do the clustering and you need to do the unsupervised learning. So in the unsupervised learning, we don't have any target feature available. So that's why we can't check the accuracy of unsupervised learning. But in the regression and classification, we can check the accuracy. Unsupervised learning just to divide the data into multiple segments. So there is no medium to tell how much your data got grouped correctly or not. At least you can find the optimal number of clusters only, nothing more than that. So in this project, we are able to discuss about label encoder. So during regression project or classification project, we will discuss about the one-hot encoder. So in that project, I will explain the one-hot encoder code. So in the one-hot encoder also, again, we will be using 2 types. So one is by using one-hot encoder library, and there is another concept called pandas get dummies. If you have time, you can go through that. So pandas get dummies. So this is also another example which will work as same as one-hot encoder. So either you can use pandas library or you can use this pandas library to convert our categorical data into numerical data. So we'll discuss this one-hot encoding and the pandas dummies during our next project. The day after tomorrow, I will try to start a new project. Clear, everyone?
Yes, sir.
So practice, everyone. You have any doubts? And I noticed some of you guys, you're not able to find out some import errors also. Like, so some errors are showcasing like pandas is not defined, scikit-learn is not defined, matplotlib is not defined. So you are simply copying the code and pasting, but at the ending you will be getting import errors. So those import errors related to you didn't import that. In that scenario, what you need to do, you need to import pandas. If it is showcasing scikit-learn error, you need to import scikit-learn. If you are getting error related to matplotlib, you need to import that matplotlib. Okay, please practice the things clearly. That's all for today. We'll connect. If anyone having any doubt, you can ask. Otherwise, we can action. Okay, guys. Bye.